Hey everyone, welcome to the very first video on my YouTube channel Code Brew with Anirudh. I am Anirudh and here we are going to view some amazing code together while also sipping on the latest tech trends. This channel is all about making coding simple, practical and industry ready. We will explore programming concepts in depth and talk about real world applications and projects and also discuss what's trending in the tech world. Whether you're a complete beginner or someone who is looking into sharpening your skills for the interviews, you're in the right place. To kick things off, I'm starting with the new complete Java plus data structures algorithms and object-oriented programming series. And when I say complete, we will go from absolute basics all the way to the advanced concepts, interview-level problem solving, and even LeetCode practice questions. By the end of the series, you will not only understand Java deeply, but you will also have the problem-solving skills that companies are looking for. Alright, now that you know what this channel is about, let's walk through the complete syllabus of our Java plus data structures and algorithms plus object-oriented programming series. Think of this as your learning roadmap from absolute basics all the way to the advanced concepts. We'll kick things off from the foundations. First, we'll start learning the different type of programming languages. Then we'll talk about the static versus dynamic languages. And of course, we'll understand one of the most important concepts in programming, that is stack and heap memory. This will set a strong base before we even start coding. Next, we step into the world of Java itself. We'll see what is Java, why is it so popular. We'll understand the roles and responsibilities of JDK, JRE, and JVM in detail. And we will also see how Java code actually gets executed. We will learn the concept of platform independence and we'll write our very first Java program together. After writing our very first Java program, we'll understand each and every single word we have written in our Java program in detail and then understand what is it doing. We will see how to take input from a user, we'll explore the Java's data types in wrapper classes, and learn how to add comments in the right way. And of course, we'll wrap this section up with a small exercise to put it all into the practice. Next, we will move on to the third chapter, that is conditionals, loops, and control statements. Here is where your programs start making decisions. We'll cover about conditional statements, we will learn if, else, and switch statement. Then we will master the loops. We will learn about for loop, while loop, do while loop, and enhanced version of for loop. We will also explore control statements like break, continue, and return. Once again, we'll solidify it with an exercise. Next, we will move on to the fourth chapter, that is functions and methods. In this section, we will answer the big question: why to use methods at all? We will learn about the syntax of a method, different type of methods, how parameters and return statements work, and the difference between the static and non-static methods. We will also cover method overloading, method overriding, access modifiers, variable arguments, also known as var args, and the pass-by-value concept in Java. You will get comfortable with constructors, this keyword, getter-setter methods, final methods, static block, and more, with all hands-on exercises. Although some concepts which I have included in this chapter are supposed to be covered in object-oriented programming. Just to have a better understanding while we are solving problems, I have included the necessary parts in this chapter itself. Even though if I have included here, we will be covering it again in detail in the future chapter, that is object-oriented programming. Next, we will move on to the fifth chapter, that is development standards to be followed while writing the code. Before we go deeper, we will talk about writing clean, maintainable code. This is where we cover the development standards that professional developers follow in real-world projects. And this is exactly where our series stands out. Where in other videos they teach you just coding, here I'll be teaching you coding according to the development standards and the best practices that will 100% help you standing out in a technical interview. After completing the development standards to be followed while coding, we will move on to the data storage. We'll start with arrays, understand what they are, how to access the array elements, and how to create them using the new keyword. We will take input of arrays, work with the array of objects, and pass array as a parameter to the functions. We will also learn about multidimensional arrays and one of the Java's most useful tools, the array list. We'll explore built-in methods, see how array lists differ from the arrays, and practice all of this through hands-on exercises. Next is searching in an array. We'll begin with the linear search, move to the linear search on strings, then binary search, and we will also complete order agnostic binary search, which is very much important. We will also see why binary search is better than linear search in certain cases. In fact, I've seen some LeetCode questions where they specifically ask you to solve the problem in big O of log n time complexity, which is the exact time complexity of the binary search. We'll practice this with multiple problems so these concepts become second nature. Once we know how to search, the next logical step is sorting. Because in programming, sorted data makes everything faster and easier. We'll explore why sorting is so important and when to use it. We will start with the simpler algorithms like bubble sort and insertion sort to understand the core idea. Then we move to the faster ones like merge sort and quick sort. We will also explore heap sort for priority-based problems and cover counting sort for integer-heavy datasets. We will even peek at the tim sort, the algorithm behind Java's own arrays.sort method. So you will exactly know what's happening under the hood when you sort in one line. Every algorithm will be paired with exercises and complexity analysis, so you know not just how it works, but when to use it as well. Now, here is where we level up as developers. You can't call yourself a truly skilled programmer without understanding the efficiency. We will break down time complexity, what it means, why it matters, and how to evaluate performance of your own code. We will explore big O notation and understand the best, worst, and average cases with practical examples. We will also learn space complexity, how memory is allocated, and how time and space complexity trade-offs work in real scenarios. By the end of this chapter, you will be able to read any piece of code and instantly estimate its efficiency. A skill that's gold in technical interviews. Now, let's add some brain fuel. Math is the secret ingredient behind a lot of clever coding solutions. We will dive into bitwise tricks that can make your code lightning fast, factorization techniques for large numbers, prime number checks optimized beyond the basic loops, smart uses of modular operations, and key number theory ideas that pop up in competitive programming. We will immediately apply the concept through fun exercises, so it's not just theory, you will be solving problems that once looked intimidating with ease. Next comes a topic that many find tricky at first. That's recursion. But trust me, once it clicks, it feels like magic. We will start with how recursion works behind the scenes, the stack frames, the flow of execution, so there is no mystery. We will then solve problems step by step, build trees recursively, and even handle complex patterns using recursion. You'll learn about tail recursion and when it's beneficial. By the end, recursion won't be something you avoid. It will be a tool you're confident to use for arrays, strings, sorting, and even graphical patterns. Now, we arrive at the heart of Java, the object-oriented programming. This is where Java truly shines and the real-world development starts making sense. We'll begin with the fundamentals: classes, objects, fields, methods, this keyword, access control, and constructors. Then we'll go deep into the core principles: inheritance, polymorphism, overloading, overriding, encapsulation, and abstraction. From there, we'll move into the special topics like static and final keywords, packages, enums, annotations, singleton classes, and the important methods from the object class. Finally, we will explore advanced Java features: generics for type safety, the collections framework, vector classes, exception handling, lambda expressions, and more. All of this will be backed by real coding exercises that feel like actual project work. So you're not just learning concepts, you're learning to use them the way professional developers do. Once you understand object-oriented programming and data manipulation, it's time for stacks and queues. Two fundamental data structures you will find everywhere. We will cover stacks first, what they are, how they work, and their push-pop operations. We'll compare push-efficient and pop-efficient stack implementations. Then we will jump into queues, including the standard queues, circular queues, queues using stack, and stack using queues. By building them from scratch, also using Java's built-in implementations, you'll see both the theory and the practical side. Next, we make our data structures more dynamic with linked lists. We'll start with singly linked lists, then move to the doubly linked lists. We'll learn how to insert, delete, and traverse through them, and we will even reverse a linked list in multiple ways, that is, iteratively and recursively. We'll explore circular singly linked list and circular doubly linked list so you know the full range of possibilities. And of course, we'll practice with plenty of exercises that make you comfortable with pointer manipulation. Now, we step into one of the most powerful data structures in computer science, trees. We'll start with the basic of tree terminology, then build a binary search tree from scratch. We'll explore different traversal methods, that is, depth first search and breadth first search, and learn their use cases. We will move on to the advanced trees like AVL trees for self-balancing and even segment trees for range queries. You will not only understand trees theoretically, but also implement them in a ways that they could easily appear in the coding interviews. The next chapters are HashMaps, Heaps, graph theory, and dynamic programming. I haven't added the detailed syllabus yet for these chapters, but I will be planning the syllabus soon and updating this file in the future. So this roadmap will keep getting richer and even more complete. And that's our complete roadmap. From beginner-friendly to advanced interview-ready concepts, this series is designed to take you from someone who is just starting out to someone who writes clean, efficient, professional-grade Java code with a deep understanding of data structures and algorithms and object-oriented programming, and to someone who is ready to shine in the real-world development and technical interviews as well. If you found this video helpful and you are excited for the journey ahead, make sure to hit the subscribe button, give this video a like, and share it with your friends who want to level up their coding skills. Also drop a comment below by telling me which topic you are most excited to learn. I will be reading them all. Thank you.